So we got the band back together.
2/3 of the band back together. So this is a special edition grab bag, and I see we've broken it up into 3 categories.
So
it's both.
It is both on the scales.
Circumstantially.
Right, in the circumstances that we are.
Circumstantially,
so
they're both.
The exceptions come in extreme environments when you're not looking at sort of Earth-like or local environments. One example is a black hole. Right, where you might indeed have a circumstance where you can tell the difference between a gravitational activity, curvature, space-time gravitational activity, and a force that measures out exactly like that curvature.
But how much of this is just semantics? Like, who cares whether it's curvature or Newtonian? If it accelerates an object, and let that just be the force. It's a baseball thrown at 90 miles an hour.
Yeah.
Yes.
So you have this huge amount of stuff that's there, even though there is no mass.
Gotcha.
So given that, one of the mysteries of the Standard Model and how our subatomic universe works is indeed what has mass and why, and what doesn't have mass and why.
Right. And so can you call energy potential mass?
You could.
You could call it that.
Yes.
Okay.
But what happens now, we have to bring in Tom's concept of quantum physics, right? General relativity and quantum mechanics have a real hard time connecting with each other. When you try to use these ideas of particles to explain gravity or the motion of things, you get stuck. The theory, the math doesn't quite match.
Right.
But it still wouldn't translate out into our universe.
How would you ever find out?
Right.
Because you can't get any of the information out of the black hole.
So the math works in these speculative
what happens
ways.
In a black hole stage?
As far as we know, right?
The Cosmic Fight Club.
Never gets mentioned.
We don't talk about the event horizon. Yeah. So
Fight Club. And up to the geometry of what's going on.
Yeah.
But also, he did comment on something that I wish were true, but it's not the betting person's odds for it to be true.
Right.
That the dark matter,
yes,
what we call dark matter, is ordinary matter in another universe whose gravity is spilling into our universe.
Right. That was Tom's concept, right?
Yeah.
Yes.
Yeah. So I'm all for that, even though I know dark matter is probably some more exotic particle.
That's right.
But that wasn't directly related to the black hole question. It was just a side point. So on a flat surface, the strength drops off as 1/r.
Gotcha.
If you are a
volume,
so that's 2 dimensions, right? And in a 3-dimensional volume, the strength drops off as the surface of the sphere gets bigger.